And one more thing before Mike starts, that I'll have a two-question survey at the end of this presentation. Please, I would like to request all of you to do this survey. And if you have any question, you can put on the feedback or comment section on the chat box, or wait until the presentation ends so you can directly ask to Mike. Thank you.
Thanks, Aviv. Should I just go ahead?
Yes, please.
Okay, I'll kick it off. All right. Thanks, everybody. Thanks for inviting me, Aviv, to give this presentation. Really interesting time to talk about weather, as it always is here in the Southwest. Rounding almost the middle of our 2026 monsoon, and a very strong El Nino event is actually forming over the last several months. We're going to actually talk about that and both of those elements today. So we're going to talk about the monsoon season as it is right now, expectations for how it might evolve into the fall, what the fall weather might look like, and then into next winter, all in the context of this strong El Nino event forming. So what I want to do today is, it's going to be a lot of maps, a lot of figures. It's going to be recorded, and we'll have time for questions, so we can kind of dig into any of this if there's any questions at the end here. And I want to make this distinction between how the weather works here in the winter versus the summer, because we're in the middle of the summer season. The way that we would look at weather maps is going to be one way. And as we transition into fall and into winter, we're going to look at the maps slightly differently. And I want to make that distinction because the way that El Nino actually expresses itself on our weather pattern evolves over time, especially from the winter into the summer. Sorry, summer into winter. So we're going to look at a lot of maps today, but I want to make this distinction now, and just the way that I'm going to be talking about weather maps is a lot of the ones you'll see maybe on the Weather Channel or on your weather apps. You're going to be looking at surface maps where high and low pressures systems are. That's a little tricky to interpret when you move out west with all of our mountains. So a lot of us in meteorology and climatology like to look up in the atmosphere. So we're going to look at the 500 millibar level. It's below the jet stream, but it's still going to give us a sense of where high pressure systems are, big broad ones like the one that brings in the monsoon, which is our large subtropical high pressure system that builds across the Southwest. Those are ridges that push north. That's going to be all that warm air from the equator moving north. And then the troughs where the cool air from the north starts to move down towards the south. And so those waves translate where the jet stream is above it, and then also where those storm tracks will be as well. So, and this is part of that distinction I want to make, is that the way the weather works in the summer versus the winter is different, how El Nino will impact that too. So when I'm looking at some of these maps, you can look at this left figure here and just think about where those ridges are, where it bulges to the north. At the surface would be typically high pressure. And then the troughs where it dips to the south is going to dictate where lows would be at the surface. Again, the atmosphere is really complicated from low altitude to high altitude. It's never going to be perfect in any map, but we can infer things by looking at this, what we call 500 millibar map. Okay, and so just a simple cartoon graphic here to draw this distinction between the winter circulation and the summer is, let's just first think about the winter circulation pattern. And the weather across the United States is part of mid-latitude weather systems. What that means is, in the mid-latitudes from 0 at the equator to 90 at the poles, in the mid-latitudes, 30, 40, as high as 50 degrees north latitude, is going to be that dividing line between cold air to the north towards the poles and that warm air towards the equator. That temperature gradient from the equator to the poles drives the weather systems that we experience, and especially when the gradients are tight, meaning that there's lots of cold air in close proximity to warm air. And so in the wintertime, you can imagine that cold air, as it sneaks to the south, is running into that warm air that is typically over us and towards the equator, that strengthens and enhances the jet stream, and that's going to be that storm track. So typically what we see here in the Southwest is we're under what we would call a ridge of high pressure. There's a broad high pressure over the East Pacific. And with that, at the upper levels, is that bulging north of the high pressure. And that large ridge typically steers the storms up through the Pacific Northwest. The cold air drops to the Midwest. And so that storm track is really from the Pacific Northwest down through, say, the Ohio Valley and back out. And again, it wiggles and waves all over the place through the season. And El Nino actually changes that. We're going to talk about that a little bit later. But just climatologically, that storm track is typically in the north. Occasionally, half a dozen times, if we're lucky through winter, we'll have a good storm system where it'll pull that jet stream south into the southwest, and we'll start to see those storms drape across us. Pacific Northwest is wet all winter long. We have those occasional wet spells, and we can also let that ridge be too strong, steer the storms away from the southwest and get stuck into drought periods. Okay, and so when we're thinking about the moisture and where that comes from, we can see where that high pressure system really is located by looking at a climatology of moisture here. And this is just simple kind of up above the surface, say 8 to 10,000 feet, the relative humidity. And the reds here indicate that that's dry air, and the purples indicate that that's going to be moist air. So this is for the winter season, December through March was this particular plot that I pulled. As you can see that dry air just out over the East Pacific and nudging into Southwest Arizona, and we're in that gradient from north to south. So that's our typical air mass. We're typically in a dry air mass almost all year, and in the wintertime, it's got to get shoved out of the way to actually get the precipitation to come in here. Okay, so the season that we're in now, and you might recognize if you've been watching the weather maps, doesn't look like anything like the wintertime. There is no storm track across the US for the most part right now. It's up over Canada. The jet stream retreats to the north because the whole northern hemisphere is now bathed in lots more sunlight, and that cold air is retreating across around the poles. So that temperature gradient goes all the way up into Canada. And now we're under these big, broad, high pressure systems due to the rising air at the equator just getting dumped down back to the surface over the mid latitudes. And so our big subtropical high expands and strengthens and moves north. And that is the building of the monsoon ridge that we actually expect to see from June into July. And we need it to actually move north of us to actually pull in the moisture from the tropical air mass to the south. And so that is what the monsoon is a change in wind direction from that dry west southwesterly flow to a south southeasterly flow, pulls the moisture into the southwest, and that's where we start to see our thunderstorm activity if we're lucky. So this map is now June through September, and you can see that that dry air mass that we were talking about in the wintertime now is now it's still over the Pacific because that's cold current coming down the coast there stabilizes the environment. Right above that humid environment is actually extremely dry air. And now it's nudged up to the north. And, you know, if you've ever driven up into Vegas out of the monsoon, it dries out immediately, gets very hot. And in California, you know, you typically don't see much of any precipitation during the summer, except if you get tropical activity. But look to the south there is that there's that tropical moisture moving up, tropical air mass now being pulled up into the southwest. So that's what we're going to talk about today is first, we're going to focus on the summer. How does the monsoon work? What have we seen so far? Then we're going to shift gears. We're going to talk about El Nino. What is it? And what are we seeing right now? And then how might El Nino be impacting the current summer outlook, then into the fall, and then into the winter? Okay, so first I want to start off and I'm going to dive into that just a little bit deeper. You've got a pretty good background now on the idea of this transition as we go from winter to spring to summer of the monsoon building into the region. And so just to animate this a little bit more is we're going to look at this again, that 500 millibar level. So about 15,000 feet, not at the jet stream where you take a jet flight, but kind of in the middle. And it's kind of a neutral part in the atmosphere where it helps us understand what goes on above it and below down to the surface. Looking at this broad belt of high pressure system. And remember, in the northern hemisphere, the circulation around a high pressure system is clockwise. So below these H's, the wind is coming from the east, moving towards the west. And then north of that, the air is moving from the west to the east. And those colors are giving us an indication of heights in relation to temperature. And those gradients, you can almost think of them as like on a topographic map, isolines. And think about when those isolines are packed close together, you've got steep gradients. And so the jet stream and the storm tracks would follow those steep gradients. So looking at Arizona here in May, we're still in that greens to purples, meaning we're in that tight gradient. And you can remember in May, it's usually the days are longer. We're getting lots of dry, hot wind out of the southwest. And that's typically that pattern because the ridge hasn't built north yet. So if we click it forward, we go to June, you see the colors brighten up across the whole map because the whole northern hemisphere is warming up. That ridge is expanding and building in strength, and the gradient slackens a little bit, and we're still in southwesterly flow, again, north of that high pressure system in June. And then as we click into July, then the colors really pop out, the ridge strengthens, and we're getting that high pressure system somewhere overhead. Ideally, it's off to the east, or it's to the northeast of us here in Arizona. Because if you're right underneath the high, then you're going to bake under the sun and it's going to be very hot. And that may sound familiar because that's actually where the high has been parked for the last couple of days. It has just today shifted off into eastern New Mexico. And it does move all over the place through the season, but in general, its average position is going to be up over the southwest. Once it's in position, and you can see south of the H is now, there's broad easterly flow. You're now in the easterlies, like you'd see across all the tropics. That's where that tropical air mass is now going to be able to flow into the southwest and give us the humidity and the moisture that we need to drive the storms. Okay, so this is there's a lot going on here, but I just want to draw your attention to, this is a climatological progression of just what we talked about here. So the top row is going to be June, and it's going to go through July, August, September, and October. And those gray lines are the height lines we looked at, like on the previous map. But all I really want to do is draw your attention to the H, and that's the climatological center of where that ridge is, or the high pressure system. And just with your eye, track it from left to right. So we'll watch the H in June, pop up into the southwest in July, kind of wander off to the east in August, and then quickly retreat in September, and then definitely retreat into southern Mexico in October. So you can see how subtle and quick the movement of the ridge is up into the southwest. The other thing here on this map is that that gold line is it's kind of a nice way of demarcating the deep tropical moisture. So it's imperfect, but we can think of that as the dividing line between the dry continental air we typically see in the southwest in April, May, and June, and then the deep tropical moisture to the south. So you can watch that line quickly move in June to July up. The gold line cuts Arizona in half, and you can see the low deserts fill in with that green color, which is we call precipitable water. It's going to be the humidity and the moisture. And then in August, kind of parks there and quickly retreats. In September, you can see if you're down in Yuma and on the Gulf of California, it can still kind of literally little waves of humidity will lap up into the low desert. But then by October, we're usually into that the beginning of the winter storm track, and it's shifted the weather out of the west, and now that is pulling dry air in again. So it scours out and ends the monsoon pretty abruptly September, and then we're definitely out of it by October. And then at that bottom panel, you can just watch the precipitation build up through Mexico in June, get into the high country typically of Arizona and in New Mexico in July, hang out in August, and then retreat again in September and October. So that's the natural progression, noisy every year. All right, and so just to reinforce this moisture issue is, and I think we all know this living in Arizona, especially if you're working down in Yuma, and it may be interesting to you if you're in Phoenix, is that that humidity that you're seeing is coming out of the Gulf of California. That's the main driving source for most of the precipitation that occurs in Arizona during the summer season. And so there's this was a cool study almost 10 years ago now, but just look at the lower left panel, walk you through it. There's a little black dot there, and that's at Levine. I'm not sure why they chose that location. There's a weather station there that they use some data. And what they did is they took all the rain days at Levine during the summer and then ran a model backwards from each rain event and tried to figure out where did the moisture come from those particular rain days. And so that little heat map gives you an indication of the counts of where that parcel of moisture originated from. And they're in south central Arizona. They almost all of them are pointing back into the Gulf of California. So that 85 to 90 degree water in the Gulf of California, just pumping out lots of moisture to the atmosphere, and a nice coastal plain up into the low deserts of Arizona is just a nice way to see that moisture kind of move in. And there's A little interesting heat map there too. It looks like some of that moisture sneaks around a pass in Baja where the elevation of the topography is allowing it. Otherwise, it's damming up, which is typically cool water off of that coast there. But if you look at the Red Rock, which is in that lower central panel, is right on the Arizona-New Mexico border. In that area, you can actually get Gulf of Mexico moisture that'll come right up out of Texas all the way over to there, or interacting with all the moisture we're pulling up into Arizona on the Gulf of California side. Then once you get off into eastern New Mexico, it's shut off from our moisture source in Gulf of California, and now you're talking about Gulf of Mexico. So just thinking about that, where those moisture sources are. And then put it all together. This is typically what we see across the Southwest, very elevationally dependent. The mountains typically see most of the rainfall and actually generate and drive a lot of the convection and the thunderstorms that we see. And you can see that carve out as soon as you go down in elevation from Tucson to Phoenix. You drive downhill a bit and the precip does fall off, and you drive downhill more from Phoenix to Yuma, it drops off even more. And I think you know that working out there is that not particularly wet. You'll get a couple of events maybe in a season, not every year. And sometimes those events can be very heavy. Okay, so that's your primer on how the monsoon works. And let's actually look at how 2026 is working so far. Okay, so these are some maps I generate with a product that NOAA produces. It's kind of an interesting product. It uses the radar that you'd see on your phone app, and also uses gauges at the surface, and it makes these daily estimates of total precipitation on this 4-kilometer grid. And so you get it does a nice job of resolving very fine scale thunderstorm activity and can capture some stuff. It does make up some things in between gauges, and it also has some issues, especially over the Four Corners region, where the radars don't actually see close to the ground anymore, and so it misses some events. And there's a little bit of an issue around Safford as well, where it'll run drier than it probably is based on gauge observations. We just don't have a lot of gauge observations outside of Tucson and Phoenix, so it makes it a little more challenging. But total precip so far this season, you can see along the Mogollon Rim, Show Low seems to be a little bit of a donut hole, but if you go through parts of Tano or through Gila County and then into Yavapai County, especially on Prescott, I've heard from some folks in Prescott that they've seen quite a bit of precipitation so far. And then down along the border from Bisbee to Sierra Vista to Nogales, they've had quite a bit of activity there as well. And so those are some pockets in that right map right there where you're seeing above average precipitation, a lot of kind of pockmarking across the state. Some areas have raced ahead and are above average. And it's interesting to look across Southwest Arizona. A lot of those areas are average to above average, but the totals are quite low because climatologically through this part of the season from June 15th to present, you wouldn't normally see a lot in the season. So even a little bit of rainfall has pushed those areas to above average. We can total these daily totals up into different ways. And so here's a map in the upper left is how many heavy rain days, just counting in a particular grid cell, how many days have seen at least half an inch of rainfall. And you can see around Prescott, just off into Gila County again, and then down around Sierra Vista, some of those locations have seen 6 to 8 half-inch days, which is pretty impressive, pretty isolated. You can look at the rest of the state has not seen that much. I certainly haven't in the east side of Tucson seen much activity at all, and I appear to be in a little bit of a hole there too. But I think a lot of us would argue we're there many seasons on end. And then this map in the lower right is just looking at wet spells. They do correlate somewhat with where those heavy rain days are. A wet spell is consecutive days where that location is seen at least 0.05 of an inch. It's an arbitrary, so it's a little more than a light event of just 1/100 of an inch where a gauge would catch it. So push that up a little bit. So is it something consequential? 0.05, and then how many days in a row since June 15th have these locations seen? You can see up over the highest elevations in the Mogollon Rim in Apache and Navajo counties in the southern parts of them. Some of those locations have seen 12 to 14 days in a row of precipitation, so afternoon convection over and over again. If you go down to southwest Arizona, the low deserts, maybe a day, maybe 2 days in a row, and that's it. We've really only had two events of consequence so far this whole season where we'd see widespread activity. All right, and we can take the map that I showed earlier, which is the percent of average precipitation, take that every day, and then just basically bin it out and then map a time series here. And so we can see this starts on June 15th, and it's the proportion of the state covered by one of these color bands. And so below average, less than 75% of average on any given day is that brown area. White is near average, 75 to 125. If you're above to much above, you're 125 to over 2 times normal or 200%. And so we started off on June 15th, actually right off the bat, a little bit of tropical moisture kicked it off, only caught a little over a quarter of the state at that point, pulled it above near average to above average. Most of the state was below. The next rally was short-lived towards the end of June, and then we really dried out after that. And I'll show you a couple maps on what happened there. And it wasn't until after the 4th, well, actually after the 10th of July, that we saw the weather patterns shift around and start to give us a good rally, a good solid rally for a week or so. And that pushed the state up and expanded out to, well, almost 3/4 state is at near average to above average at this point. All right, a couple more plots. This is the Phoenix area, and it's just totaling up since June 15th, daily total precipitation. So by this time, at the end of July, Phoenix should be at just shy of an inch of precipitation, and they have seen 4 events and just shy of half an inch. So they're lagging behind. A lot of dust, a lot of wind so far, but not a lot of precipitation. And temps have been hot, kind of up and down. It actually cooled down mid-month with that precipitation event, and then has really pushed up into near record heat the last week or so. And then Tacna, which has got a nice long-term station, just not quite halfway between Phoenix and Yuma, has seen 3 days and just shy of a quarter inch of precipitation. They should see by this time about a half an inch. So as you go towards Yuma, it gets drier. But so they're about half of expected as well at this point, too. All right, and then just looking at this evolution, just kind of, we don't need to focus too much on this, but I want to tell that story of the monsoon evolution so far. These are 5-day average weather maps as you scan them from the upper left, 10th of June to June 14th, in 5-day chunks moving forward all the way through just a day or two ago. And it's the same as I showed you that climate map before. That gold line is the boundary between the deep moisture and the dry air to the north. And that H is going to show us where that monsoon ridge is. And you can see the panels across the top row, that brown color and that of the humidity and the precipitable water is to the north and really hanging across Arizona. And look how brown the colors get in June 30th to July 4th, which is when we ended up having strong trough out of the north, push the monsoon moisture way south into Mexico. And it was also on the heels of some fires breaking out across parts of Arizona, and especially in Utah and Colorado. And that was a big fire weather event. But then as we moved into that bottom row, and if you look across to the middle right there, July 15th to July 19th, that gold line is racing north. The H is now up above the Four Corners, big bulge in the ridge, and it really pulled a lot of that monsoon moisture up into the southwest. And we started to see, that was our best rain event so far across the southwest. And as we get into the more near recent, that you can see that H is now over northern New Mexico, big broad ridge, and the precipitation and humidity are kind of hanging out near average. And this is across the whole domain here of, it tracks with the precipitation. And we see in the middle lower plot there where we saw that big rally in precipitation across the southwest. And as we move into more recent periods, the July 20th to July 24th, northern Arizona did pretty well. And then it has dried out since. It's gotten very hot. The humidity's here, but we're now lacking the mechanisms to actually drive the big thunderstorm outbreaks. And so it looks good on a weather map. We're just not getting the precip with it. Okay, and if we look at just a couple more metrics here within the monsoon, this was interesting to me, and I double check and make sure this was right. But the mean daily temperatures are just slightly above average for the last 30 days, and we've had a roller coaster of up and down. And in the last week, we have now pushed into near record territory, but that roller coaster has averaged out to about average to a little bit above average. And so some of those cloudy, rainy periods within there has dragged down the monthly average. So it'll be interesting to see when we update this through the end of the month, which is just today, and finalize this map. And then the other element here, I pulled this up, was mean daily potential evapotranspiration. And I believe this is from Climate Mapper, and they're using Penman Monteith. Interesting leaning average to slightly above average. And so I know Jeremy's on here and he can comment. I did pull the ASMET data, but be interesting. I think the humidity has been high, and some other elements maybe have dragged the humidity up, but then the ET is below average just slightly. So average to slightly, I'm sorry if I said that incorrectly. Average to slightly below average ET levels because I believe it's high humidity that's settled in the region. And I pulled up a broad station that was out in Yuma to track daily mean dew points. And again, we should do this with the ASMET data. It has been, especially since that dry period in late June, big race up in daily mean dew points, and we've hung out above average, above that blue line. The red line is this year, the blue line is the long-term median, and believe that that's the indication of just a soupy atmosphere lowering PET. Okay, so that's you're bringing us up to present on the monsoon, and so let's talk a little bit about El Nino. We'll kind of put it all back together. What does it mean, and how does it all fit together? All right. So in some of those previous slides, we talked about the mean circulation from the winter to the summer and how they fit together for Arizona. So let's like pop it up another level here. And that upper left figure right there is on average the mean circulation. And again, this circulation is completely emerges from energy surplus at the equator and an energy deficit, heat deficit at the poles. And so all of these circulations in the atmosphere and in the oceans as well, let's talk about the atmosphere right now, emerge because of these temperature gradients from the equator to the poles. And so the fact that the Earth spins causes these movements of energy from the equator to the poles to break out into little eddies or these closed circulation patterns. And so if you go to the equator at the surface, the wind blows from east to west all the way around the planet. And those are the easterlies. So we think about the easterlies at the equator. They're blowing from the coast of South America all the way across the Pacific towards Asia. And north of that, that's where a high pressure system is. Think of these kind of as gears. That high pressure system is rotating in a clockwise fashion. So north of that high is winds are go from west to east, and south of that, you're in the easterlies. Okay, so if that whole water body across the entire Pacific basin is baking in the sun and the wind is blowing from east to west continuously, what ends up happening is that the warm water at the surface, and we got to think about the ocean too, is it's warm, it's just like a pool that is not messed with in the summer here in Arizona, is that there's that layer on top that's in the sun and heating up. And just below it is cold water. Well, my pool's not very cold anymore because it's been so hot all over, but just maybe at the beginning of the season, it warms up the surface cold at depth. And that's something called a thermocline, is where it goes from warm to cold, and that's stable. But if we blow the wind across the Pacific, it's going to take that lens of warm water at the surface, move it all the way across the Pacific. And what has to happen is that water's got to flow back in where that water is moving away from the coast, and it comes from below, and that's cold water. So there's a cold water body off the South American coasts. And then if you get out to the central and western Pacific, the warm water is there. So that's under normal conditions. So we'll really focus on El Nino today, but La Nina is the flip side of the coin, is that if the easterlies break down or get disturbed in some way, that constant motion from east to west that's moving the water out in the sun away from the South American coast to the Western Pacific, if it breaks down, some of that water is actually going to slosh back, and it's going to now not have the mechanism to move it away from the coast, so it'll heat up. And that's exactly what we've seen over the last basically 4 months, is a disruption in the easterly flow. And it was typhoons in the West Pacific started to break down the easterly flow, the easterlies, and start sending these pulses of warm water back to the east. And so, well, why does that matter? We'll talk about that in a second, because who cares? These are sea surface temperature patterns. The reason we care is where that warm water is connects with the atmosphere, drives all of the weather patterns across the northern and southern hemisphere through seasons. Okay, so this is interesting too, is that this top is a map from, you can see all the way in West Pacific, Indonesia, and you can just see the coast of Central America and off the coast of South America. And this is basically measuring, we do this with satellite, and we also have instrumentation in the ocean that goes down hundreds of meters and samples temperatures. And so you can get this map at the top here, which is sea surface temperature anomalies. And then this is a cross section. So the top is plan view looking down. The bottom plot is a cross-sectional view down in the ocean, where that dark band is up at the top. And these colors on here are bonkers. First off, the color ramp on here, I've never seen colors quite like this, but anything that is reds to these new colors on this color ramp are showing warmer than average. And so that means that there's warmer water closer to the surface than there normally is. The stash line is normally where the climatology is, and the black line shows where it is. So it means that the warm water is deep and pushed down in the eastern Pacific. So that means there's a plentiful pool of warm water to work with over 6 months now going forward. And so this comes across in waves, and we've been watching that. And there are additional waves of warm water coming across even as we speak right now. And this typically doesn't happen until later in the summer. The fact that this has happened over the May, June, July period, it means it's way ahead of schedule of a normal El Nino event. And we can look at this, again, the maps here. The La Nina produces a band of cooler than average water across the Pacific, while the El Nino is warmer. So that's what we were looking at before, is now there's warmer water replacing what is normally cooler. And most of what we're looking for is in the East Pacific. Okay, and the who cares part of it is that when you have an El Nino event, you have all that extra warm water in the East Pacific. Thunderstorms like warm water. They emerge in the tropics where that warm water is. And that area is typically cool water, so we don't see thunderstorms. We're now seeing thunderstorms in the East Pacific, and they're big clusters of storms that then have large areas of rising air. And that rising air spreads out into the northern and southern hemisphere, sends out waves, and disrupts the storm track through the summer, into the fall, and into the next winter. So we can already see that happening right now. And then what does that look like? The left is a La Nina, as Avik talked about earlier, is that usually shoves the jet stream in the winter up over the Pacific Northwest, parks it there. They're wetter than average, and we're drier than average. We get fewer storms during that situation. And then an El Nino breaks down that typical pattern, and it strengthens a subtropical jet, which in a good El Nino event screams all the way across the Pacific from the coast of Asia across the Pacific, and then will direct storms up and down the California coast and then into the Southwest. So typically strengthens that subtropical jet. Okay, so who cares? Again, we are living through an El Nino event right now, and it's pretty remarkable. And so this plot is since May 1st, steady climb from just above average to now over 2 degrees C. And we would be interested in anything above half a degree to a degree, and now we're at 2. And this is a new index called the Relative Oceanic Nino Index, which takes out the long-term trend from climate change and basically rescales it so it doesn't look like a large long-term trend, but puts it in relative terms. And it's over 2 degrees, which would be a strong event, even which being 2 degrees in the summer is unusual. It's usually peaks in the fall, and so we're a couple of months ahead of where we normally would be. And this map in the lower right shows us that the temperature patterns are consistent with that 2 degrees C rise. And so I now want to walk through just what does it mean for the forecast now. And so in the summertime, the research has shown and the correlations have shown that El Nino events don't do a lot with the monsoon because they typically haven't formed or been healthy enough to mess with the monsoon. That usually happens in the fall. And what we talked about too is their impact is usually on the jet stream position and strength. And so we're not playing with that right now. But we do know that when we have a strong El Nino event, that we typically will see correlations like we see on these maps. So June already happened, and it was pretty consistent with what we see in these correlations. But blues mean that the particular month is below average precip wise if there's an El Nino event, and reds mean that there's more precip. So correlation wise, these whole southern tier typically sees less precipitation than average during a strong El Nino event. So we're already bucking the trend. I think we got lucky, quite honestly. Got lucky because of some other factors, but this is good because we could have gone really late on the monsoon and really dry. So we move into August, though, the correlation weakens, so it's pretty much no correlation. And again, these correlations aren't very strong anyways. And it does shift to the north of us as they typically will see more rainfall during a strong La Nina. Again, correlations are weak, but that's usually because there's an enhanced midsummer storm track. And so that could give us indication that we're going to struggle with the monsoon ridge position. And then by September, it's interesting, you know, that now Western Arizona, Southern California, up to the Great Basin into Utah come up in a positive correlation, meaning during an El Nino event, these areas are wetter than average. And that's usually because the East Pacific tropical storm season is busy. And it's been pretty busy, but they've been going out to sea. By the time we get back into September, they start to recurve back into the southwest. All right, so another way to look at this is a cool old set of graphics from the Western Regional Climate Center. Says a lot what I just said here too. This left map, these are just looking at wet extremes. And so it's looking at the top 20% wet periods in a historical record. And you look across the Southwest, it's basically white with no colors, meaning that there's no systematic shift towards it either being wetter or drier for the whole monsoon season. So the relationship overall we know is statistically weak. So it didn't give us a lot of indication if we'd go one way or the other for the whole monsoon season. So the forecasts have been we just haven't been sure. And so we're doing a little better than expected, but could be a little bumpy from here on out. But it's interesting, you shift 1 month forward, August, September, October, look at that blue. The blue means there's an increased risk of wet extremes during El Nino events. And it lines up pretty nicely all the way over, especially into Western Arizona. And I do believe this is because of past historical tropical storm events that have come up through the Southwest during El Nino falls. And so that will be interesting to see. Okay, I'm going to skip that and just look at, this was 1997. Actually, this map right here was showing the 1997. And I just wanted to point out Hurricane Nora this was a strong El Nino event, very similar to the one we're seeing right now. We're actually a little bit warmer and ahead of it as far as warming, and busy tropical storm season. And there was 2 storms late in the season that made a run at the West Coast here, and Nora in particular did run up through the Colorado River Valley and produce some flooding impacts late in September that particular year. And this is just that map from 1997, and you can see here that the whole Southwest was kind of mediocre, especially Southeast Arizona. Again, that's because as a season, sometimes it takes offline the early part of the season, and we missed that July, so it's hard to catch up. But the Western Arizona and the Colorado River Valley did well because of that one event. Well, maybe not well if you're looking at flooding and impacts to cropping systems. All right, I'm gonna skip that one and look at the overall forecast now. This is a national multi-model ensemble, and this is for August through October. And so this is an actual forecast, not looking historically now, but it's a dynamical model. It looks pretty similar to what we were talking about earlier. And you can notice just the enhancement of the blue and the greens all the way into the East Pacific, up through the Gulf of California, up into the Southwest. I think it's really latching on to this idea that as we get later in the season, the East Pacific gets busy and there's more of a risk for those storm systems to come up into the Southwest. And that's certainly what the seasonal outlook looks like for August, September, October, consistent with the actual modeling there. Okay. Okay, let's shift gears and now move it forward. Let's take it into fall and into winter. All right, just to continue to kind of highlight how interesting this event is that it is in historical record, which you have to look, there's different data sets, but the best go back through 1950, and some reconstructions will go back through the 1800s through ship records and other methods, is that right now this is the strongest. It may not peak at strongest. We have to see how it all plays out, but right now is running ahead of some of the other big events, especially in the last 10 to 20 years. And the outlook here, these are 3-month seasonal outlooks by the Climate Prediction Center. And first off, you very rarely ever see them touch 100%. These bars are usually shorter because there's uncertainty in the outlook. But since El Nino is already present, since it's a large body of water, of warm water, it's stuck here for a while. And so 100% forecast all the way out through December, January, February, and it just comes off of 100 by January, February, March. It starts to fall off in the spring, which is what you'd expect. But the length of these bars is what's the probability of it being a very strong event? By October, November, December, it's over 80% chance it'll be a strong event. It already technically is in the dailies. We have to see how it averages out over these 3-month periods. So we're looking at a strong event, most likely. And then how does that actually shift the weather pattern in, say, October, November to December? This is the OND, and it's looking at the increased risk of warm or cold extremes. So this left map here is a slight increase in the risk of cold extremes. Again, don't think of this as a risk. I don't think of freezing events. It just means the way this is calculated is the bottom 20% of temperature. So this is an increased risk of the coolest extremes. And we have a lot of temperature trends, so I don't think we'll really realize this, but you can see here that those areas that have wet conditions typically are cooler because of clouds and rainfall, so it pulls the idea of you getting into it. I don't think this is a shift towards freezing event risk. We just don't typically see those with El Nino events as much. But the wet extremes really do pop up across the whole southern tier. You see almost every Arizona has almost a twofold increase in wet extremes. So in the top 20% of wet years in the upcoming fall. As we shift that forward to January, February, March, see we fall out of that. There's not necessarily a shift in those cool extremes in January, February, March, but the wet extremes does shift now towards most of Southern California, all of Arizona, and almost all of New Mexico as well. So historically, we see wetter extremes with these El Nino events.
Okay.
And then, so just finally here to wrap it up in a couple of slides here is let's look at Yuma. This was during the strong El Nino of 97, 98. And this is living through a couple here in the Southwest is what I remember. And one in particular sticks in my mind, which was winter 2009 and 2010. Wasn't even a strong event. It was a moderate event, but came on quick, produced a pretty interesting set of storm events. And that's usually what we'll see is it's usually not a bunch of rain events spread out through the whole season. It's little clusters where the jet stream, the storm track gets focused at Arizona and then delivers a couple of quick, heavy hits, retreats, and then we might have a chance to dry out or maybe not. Cloud cover might be more frequent through the season, and I would expect that since there's so much warm water in the Pacific, that humidity would be up as well for extended periods of time, more than we're used to seeing it kind of dry out in October and maybe sometimes even in midwinter as cold air masses come in here. But in this particular event, a couple of heavy hitters in December, and then you can see here in January, almost no rainfall, just a tiny little event here in Yuma, and then February got busy, and then again March. And that's a lot of times what we see is later in the season in little clusters of heavy rain events. If you go up to like Flagstaff or the high country, you'll see more of those precip events and overall more precipitation. So those areas could hit a little bit more. Overnight temps I expect will be higher because of cloud cover and humidity. So I don't think you can see down here, and there's only 2 on average freeze events for Yuma in this historical record. And they didn't have any. And so I don't think all out huge widespread freeze event. It's always a risk, but I think the risk goes down during El Ninos because they are warmer. That subtropical storm track really does push in warm, high snow level storms. So this is the overall outlook. It's interesting. Climate Prediction Center is still hedging a little bit. They're not going with their full green color palette, especially across the Southwest. They do see it. They drag it out across northern Florida in December, November, December, January. But we are in that above average shift for all the way out through January. And then the temperatures actually back off. And it's just the correlation between if we end up seeing more clouds and more storm events, we don't get as warm. And so that would be something to watch for too as well. Just looking at some of the weather maps on the models is pretty interesting. I just wanted to show this to you real quickly here too, is the left is the October upper level weather pattern. So seeing that blue show up there is starting to mean that the low pressure systems are already starting to form off of the California coast, and they're going to start lining up in the Pacific Northwest and coming down the Northern California in October. And then by November on that right panel, deep purples with the enhanced low pressure system. And so a stronger storm track pointed somewhere in the Central California to Southern California coast. This is tricky. And this is the thing about El Nino events is that this could totally verify, but if the storms are just north of us, we could be watching them to the north, and California is getting pummeled with atmospheric river after atmospheric river. They're a little bit to the south and the angle's right. We could get a head on. If it's even further south, they could skirt Arizona and go right up into New Mexico. And this is what we've seen with past El Nino events. But the risk is there for a couple of clusters of heavy rain events through the fall and winter season. So just to wrap it up, and I'll take some questions here, is that El Nino's here. I think it's got some fingerprints on what we've seen so far, but it's weak, and we're getting a lot of variability within the season. There's some low pressure systems streaming in up off the Pacific Northwest right now, which I do think probably have some relationship to the strong El Nino already in place. And so we'll just have to see if it shoves the monsoon ridge out of the way and dries us out. But that risk then increases in the East Pacific as we get further into August and into September. Overall, it tilts our odds towards wetter conditions, but those storm tracks, like I talked about, are going to be really critical to watch if we're going to get hammered and clobbered over and over again, or if we just get a handful, or if it just steers north of us. And then on that climate change front is that we've got a lot more heat in the atmosphere, a lot more humidity. So anything we do get has that risk of having more extremes with it. But the overall shift towards, was this event caused by it? We still have that natural variability in the El Nino Southern Oscillation, and it's an active area of research to really understand how that might change over time. So one thing I will say is that often strong El Nino events like this are followed by strong La Nina events. So we're already, maybe a year from now, going to be looking to see what happens on the other side of this. Okay, that's all I have. I think we have time for questions. Thanks for your attention, and happy to field anything you got.
Yeah, thank you so much, Mike. So we have 10 minutes for question and answer. So you are welcome to ask or write your question down in the chat section. And in the meantime, I will share a quick survey for you. Any questions? Okay, Mike, can I ask one question?
Yeah.
So as is shown in the figures, so if we have this strong El Nino is continuing until the winter, so do we have a chance of seeing a good amount of precipitation in the upper Colorado Basin?
Such a good question. I thought it might come up. So if you look at the historical correlations
Mm-hmm.
from north to south, the strongest
Yeah.
correlations historically in the wintertime with,
Mm-hmm.
say, an El Nino event is occurring, when you look from central Arizona south and into New Mexico, those areas typically have the stronger correlation. So those are areas that typically see wetter the conditions
Yeah.
when an El Nino event occurs. If you get up to the Central Rockies, the correlation actually drops to almost zero.
Oh,
And so,
mhm.
And if you think about where that storm track is that
Yeah.
it could, if it lifts north, drag them right across the Central Rockies. But typically what it does is it's south of
Mhm.
there and it's kind of up for grabs as far as
Right.
what that
Yeah.
forecast means. I will say though that past El
Mhm.
Nino events, they're not particularly good snow producers because they're coming in on a subtropical jet out of tropical origin, so they're not particularly cold. It's only if
Yeah.
there's really cold air parked north of that storm track that it can interact with that maybe the Central Rockies can make snow. But even across to Arizona, snow levels tend to be high. So even if we get a lot of precip, we don't
Right.
end up seeing a lot of snow, or we may end up seeing snowfall and then rain on snow and then flooding after that.
Right. Yeah. Okay. Yeah. Thank you so much. And this condition is very similar to 97, 98 or 82, 83 El Nino events.
They're not. This is a trick too, is that
Yeah.
they're analogs in the sense that they're similar in strength and timing. Because those events,
Mm-hmm.
to be a very strong event, you have to get going early because you run out of time within the season to actually build the warmth. So right now, 82, 83, 97, 98, 2015, 2016 is kind of similar. That was a strange one because it
Mm-hmm.
happened over a
Yeah.
couple of years. So but again, we got to remember too, the system has changed quite a bit since 97. It's quite a bit warmer.
Mm-hmm.
And so I'm using it as sort of a rough analog to look at the rest of the season into the winter, but we will really have to pay attention to the short-term forecast and the modeling
Right.
to see
Yeah.
how those weather patterns stack up.
Mhm. Okay. Thank you, Mike.
Yeah.
Any more questions? Okay, then think yeah, it was a really good learning. Thank you, Mike, and thank you for your time. And it was a really great lesson for everyone and me as well. And I thank everyone for joining us today. I have recorded the meeting, so if any one of you need this session later, so just email me. I can share the link. Thank you so much, and you have a very good rest of your day. Bye bye.
Thank you. Appreciate it.
Yeah.